Hello, Mike and Steve. So let's get going. Steve, I saw that you had made quite some nice progress.
I'm not sure. I think I'm just sort of up where everybody else is at the minute. Yeah, like I've just been sort of like looking
So
ones.
are you running on Kaggle or on Colab?
Oh, just on Kaggle at the minute.
Oh, okay. Because something that I just wanted to share after, or when I think it's right. But there are a couple of approaches that Chris had shared, and I was just of course I ran his basic notebook and tried it with a couple of different debutter models. His thing, which gave me a fairly good result, basic, which was on small, and then extra small on the both running on Kaggle. And then because I wanted to kind of try with base or large and those things take much longer, and and opportunity to kind of maybe add more training data, as he said, because there was this pointer to training. So anyway, to make a long story short, I kind of tried to run it on Colab, and I kept getting one particular really strange error that I wanted to kind of get your eyes on it. If I can share my screen, let me see. Because this isn't even, I mean, it's not even anything very fancy. It's kind of like so basic, but it kept giving me this error. So let me know when you can see my screen.
Yeah, I can see it now, yeah.
Okay, so, all I'm trying to do is just kind of the small starter notebook that he had, and I'm running it on, base Colab thing. And I come down here, I mean, I do all the data stuff and all this stratification, everything works, all my data is in the right place and everything. And then I try to use the training arguments, from the trainer thingy, and it keeps giving me this error, right? So I was like, this is, just telling me to install accelerate or do the pip install transformer start. And so if you look here, right, or here for that matter, and then I just tried, by the way, interestingly, I had all these things installed way back at the beginning itself, which I might have commented. Yeah, see, I do datasets, accelerate, transformers, and it quietly installs all of them. And, obviously, I import them right here from transformers, import blah, 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 and it does everything without any complaints. And then I come way down here and it says, do that. And then I check with this error thingy, explain the error thing in Colab, and it said, oh, you need to probably, first it said install accelerator. I was like, man, I've already done that. But then it said, maybe you need to put that particular version and also kind of the transformer start. So I do both these, and you can see here that it says already satisfied, blah, 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 runs it. Then again, I import these things and I run it, and I again get the same stupid error.
Did you restart your notebook? Because sometimes after doing pip, it requires you to restart your notebook.
Okay. That might be the issue, because I was just continuing to try within. So
how long does it take to run to get to there? Does it take a long time?
Few minutes, so maybe I'll try in the background while we discuss other things.
Yeah, I would try it again, and yeah, so their pip install, see the one they have there, the line, the pip install accelerate -u. Yeah, like that would update it to the most recent accelerate.
This one, right? The update one. Yeah,
Yeah.
that's kind of, I do normally, I always do the -QU, which is like a quiet and update.
Yeah.
So it doesn't give me all this stuff, but I just did it because this time without that.
Yeah.
Maybe I should put in some -U. But let's see, the problem why I didn't put in a -U, by the way, is because I thought, okay, if you're installing a specific version, then probably -U is not appropriate.
Yeah.
See, because you can see here that, oh, in fact, here it says 21.0. So did I do? Yeah, I did that because of that. But otherwise, it installs the uninstalling 0.31, which is, I guess, the updated version.
Yeah. So it says as well, I think it says below, doesn't it? Either install the transformers torch.
Yes, it says either or.
Yeah, so I think I might just go with the pip install accelerate -u.
Okay.
And then, yeah, like restart your notebook as well. Yeah. Yeah, so get rid of the version and comment out the. And then, yeah, get rid of that one as well.
And then let me also get rid of what I was doing here. So maybe I just do.
Yeah.
I do main data sets, so I don't do these here. So it will complain. Okay. I'll try that. Okay, thanks. Let me.
Yeah, so I'll just restart and run to whatever line it is that was giving the error.
Yeah. Trying to here. Okay, while that is running, the other thing which I wanted to use this competition as a, excuse for kind of fine-tuning large language models and kind of learning to do this on custom data sets, because that's a good skill to have anyway, even if the score is not great. And actually, Chris, again, provided a nice starter notebook. I don't know that it's nice necessarily because he uses some custom setup that instead of using the supervised fine-tuning trainers. So I kind of, again, created that equivalent of that notebook where he is actually on Kaggle. The 2x-T4 is actually fine-tuning a Mistral 7B, or he tries to, but then he kind of says in the notebook, if you go look at that notebook, that, oh, for some reason, the 2x-T4 fine-tuning of the LLM doesn't work. So he fine-tunes offline on a V100 and then just kind of uses the same notebook to do inference and gets up to a score of about, 0.79 or something. I wasn't so much interested in the score. And then he says, obviously he's using limited version of the data set, blah, blah, blah. And there are many ways you can improve stuff. So I kind of wanted to try that. Obviously, we have more compute resources here and stuff, right? So I used the L4. Oh, it executed till then. That was pretty quick. Okay, now let's try. Miracle moment. Oh, it ran. Okay, thanks. That was it.
Well, yeah, so we didn't really end up. Yes, I'm not sure, is it because of the fact that you've like now upgraded your accelerate to the latest version, or as I say, quite often you do need to restart notebooks after doing the pip install.
Yeah, I think that's the magic. That I don't want to do anything with this now. But, I didn't see, because I had logged in and I was just playing around. I didn't realize that's a good thing to keep in mind, that you probably need to restart. Okay. That is because I was like, man, this runs on Kaggle and I have more compute, and what's this thing with? Why can't? But it makes sense, I guess. Sometimes do you always have to do this?
I think you only have to do it the first time. I think if you go in
okay.
the next
but
time,
whenever
you'll
you
probably
do
be okay.
on the fly pip install, changing anything, you need to kind of restart the notebook for it to take effect.
Sometimes you do, yeah. I don't think you always do it. I think it depends on sort of what state it was in originally.
Okay, cool. I see. Thanks. That's helpful. And then, so I was, trying to do this LLM fine tune, because it's a good excuse to learn to fine tune LLM on your own data, because this is a new data set, right? Like from Kaggle and stuff. So I have all the data loaded and everything. And I was actually trying to also do a 4-bit QLoRa from some other notebook that I had learned. But anyway, I ran into some other problems with it. But that maybe we'll defer it to next week when we talk about it and stuff. But so I kind of just tried the basic thing of fine tuning, just using LoRa, not quantified LoRa, because that gave some problems. So I did all that, followed up with everything that he was doing, get the, the pre-processing appropriately done. Same thing as what he has as in Chris's code. You tokenize it, and then you come here to fine tune. You do the QKV, blah, blah, blah. Use the trainer again to just do that. And then you do this train.train. And by the way, did either you or mine try doing this at all, or?
No, I haven't. I've only used Chris Diott's, was it Deberta, very small notebook or whatever, just like the basic one. Right. And then all the rest of the time, I've just been using the LG Boost ones.
Yeah, the additional features. I had a bunch of questions on that, so maybe once done with this, you can share and we'll go through that. But anyway, here I tried this, as you can see, right? And what's funny is on step 1, the training loss is 2.63. 125 steps, it goes to 0 and just stays there. So it doesn't seem like it's training, because you don't see the loss going down or anything. And that seems to be the case because, and then when you do this is the validation thing that he tries, and you can see that, that doesn't do anything because all of the scores are just 3. Whereas in his case, he's able to get, scores from 1 to 4. Now, the only thing I changed, and I slept on it, so this thought came to me that maybe I should remove it and try, is in his prompt, I added this single line because I thought that might be helpful. Whereas he only has in the system prompt, please read the following essay and assign a score of blah, 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 right? Which is essentially telling it to do what you need it to do, meaning the LLM, and then output just a number and with no explanation and stuff. I thought adding this might help, but I don't know, maybe it destroys its ability to do. In these LLMs are notoriously finicky with or very sensitive to the prompting. So maybe I thought, okay, I'll remove this line and then try it again. But do you guys have any other thoughts of what could be going wrong? I know, Mayank, you had shared a notebook for training Llama 3, which I hadn't tried yet because I wanted to kind of use Mistral first before I switched to Llama 3 and the notebook.
Yeah, it looks good. So how did your training progress? I mean, what was the...
Well, you can see what it did right here. Oh, the other thing I did, which is I don't know that this should make any difference, is I increased, he only had like some odd number, some 3,000 samples from the data set that he used for training and 1,024 for validation. And I thought, okay, let me, because I have better compute. And he said it took him an hour to do that on V100. Now, he might have a custom V100, but V100s are deprecated and it's on L4 that I am, which I assume is slightly better than V100. So I said, oh, let me then increase from 3,000 to 5,000. And as you can see, time is not a problem, right? It trained for 5,100 in about 40 minutes, give or take. And I just changed it by for this whole thing, but you can see what he does is he just says validation set is 1,024, train set is 51, and he was doing it for 3,072 instead 5,120. And then you come down here when you are setting up when you set up the data set, you just take the first 1,200 and put it in a validation, and then slice the remainder and throw it in from 1,024 to whatever plus train set, right? So val plus. So this train set size is what gets thrown into the training data set. So that's all I changed, and it runs, but it's meaningless because it doesn't do anything. It doesn't train. Obviously, it doesn't fine tune.
Did you try it with Chris Diot's original prompt? Did it train okay with it?
Yeah, I haven't tried that. That thought occurred to me overnight after I tried it last night or yesterday, and it didn't work. I was like, why didn't it work? What could be the things that are different? Obviously, one thing that's different is he has a 2x-T4. So given that he has a 2x-T4, what he does, and I think it's in the setup. So he also, all this is the same. Obviously, the load part, is different, but that's all set up correctly. Let me. Where is, in the training arguments, okay. So back in the training arguments, this thing, right? I didn't change any of this. Oh, I did find the case that when I ran it as is with FP16 is true, then it gave me a value error saying I can't unscale FP16 gradients. The unscale grads method is not configured to handle FP16 gradients. So I don't know how he got around that problem because I had to change FP16 to false. But then again, keep in mind that the notebook he posted, he uses on Kaggle, he uses for inference only, and it may not be exactly. He says that That's the notebook he used on V100 for training as well. But this was something that I had to fix. So that's the one other change that's different.
The L4 GPUs can use B float 16. So I think so that can work too. So if you add here,
but on that one, here is the problem that I thought of and would like to hear your opinion on it. If I train with B float 16 though, and when I'm inferring on Kaggle, which only has a P100, I believe, which doesn't have B float 16, I'm not sure whether it does or it doesn't, but I think it doesn't. Then I would run into problems, right? Because my models or the LoRa things are in B float 16 and they can't be combined.
yes.
So I would have to switch to float 16, right? I can't train on something that I can't use a format for training, which I cannot use for inference.
Yes, that's one issue.
Okay. So you agree that P100s, I can confirm that, and that was something I had in mind, but I thought that P100s don't have B float 16.
Yeah, I just Google searched it and it doesn't have it. It has the compute capacity of 6.0. The compute capacity number that NVIDIA provides every GPU with. So that's one reason that B float 16 isn't supported.
Yeah, I know. In fact, I was originally going to try it on A100s because it could be even faster, but then that's why I stuck with L4 because it doesn't matter, because even if I go to A100s, then I could use B float 16, but then I can't use B float 16 because I can't use that in inference on Kaggle.
What's the choices now in the GPUs on Colab? Have you got a runtime there a second? What are the available choices for GPUs in Colab?
Here. The V100 is gone.
Is it?
Yeah, see.
Right.
It's the A100, L4, or T4. And I guess T4 is the same as, but not 2x, right? A single one.
Yeah,
Kaggle gives you the 2x T4s, right?
Yeah, I think I normally run with T4 because it's the cheapest.
Yeah, that's true. Yes,
but,
you're correct.
Yeah,
but
I don't know how.
I was a little bit concerned about memory and GPU size because I was using LoRa and I wanted it faster. Good point. The other reason I didn't use T4 GPU is because it would be slower for me than Kaggle because he's using 2 T4s and I get only 1 T4, so it will be even worse.
Yeah.
So that's why I went up to L4. That is a good point. I can try with 1 T4, but here's the other thing that he did. By the way, this is just in the future if you folks are planning to try this as well. In his case, when I say his, I mean Chris Beard's case, he uses R equal to, I think, 32, and he puts LoRa alpha as 16. And that, I believe, is the wrong way to configure LoRa because everything I have read and used, and in example notebooks that I've seen, multiple of them, not single one, but 3 or 4 notebooks that show how to use LoRa and PAST and QLoRa, I've always seen the R to LoRa alpha ratio be 2. That means it should be the way I have configured it, which is LoRa alpha is 64 and R is 32. Or if we were to make, I think in Chris's case, and this is something else I might want to try, is LoRa alpha, he has R is, in his case, I think he has R32, but then LoRa alpha is 16, which is a ratio of 1/2. But invariably, they tell you to configure that as a ratio of 2. And by the way, this is a list which says apply LoRa or low rank adaptation to all these matrices in your model.
What does LoRa alpha here refer to? The regularization that you have?
I believe, R is the rank, and LoRa alpha, I think, oh, now I remember. LoRa alpha enable, how in this whole LoRa method, what you do is you take the original model and then you train the LoRa weights, which is these low rank adapters, if you will.
Mm-hmm.
And then when you're actually applying inference, you do the weight times X plus the adapters times X, and then you apply alpha to say how much do you weigh the adapter weights versus the original weights.
Okay.
So it's like WX plus alpha times LoRa adapters X.
Mm-hmm.
Right?
Yeah.
So that's
Yeah,
what
I
it is.
remember that. So
Yeah.
LoRa alpha is the way you read that.
The way you configure it. So this configuration says, I believe eventually it means that you do weight times X plus 2 times LoRa weights times X when you infer.
Mm-hmm.
Because this ratio of R to LoRa alpha is 2.
Okay. So LoRa alpha is like the configuration parameter that makes you read the WX plus the rank of the matrix that you're trying to read from the.
The rank is determined by R. It's the ratio of the ratio in which you combine the outputs of the original model and the outputs of the LoRa adapters.
Mm-hmm. So what's LoRa alpha refers to? So what is it only the regularization parameter that it
this comment
configures?
is from his notebook, but the LoRa alpha typically, like I keep saying, is just, to me, it's a configuration parameter that tells you how much to weigh the output of the adapters compared to the original model, compared to the output of the original model. That's my understanding of what this LoRa alpha is.
Okay.
And obviously, you can increase this R to increase the proportion of the trainable weights. So if you increase R to be, you can see that right now it's fairly small, but you can increase this to 64. And as you increase this, you get closer and closer to the size of the original matrix. Whereas right now, this reduces it to, this makes the rank of the LoRa adapters the 32. You can make the rank 16, you can make the rank 8. The smaller you make the rank, the more you're shrinking the size of the LoRa adapters in comparison to the size, in comparison to the rank of the original matrix, therefore increasing the, therefore decreasing the size of the LoRa adapters, but also causing more problems in a sense to the accuracy.
Mm-hmm.
Right, but back to Steve's question, I'm trying to see where, here. So in the training org, this thing, per device train batch size, is batch size, right? So let's go back to what I've set that as. Yeah, he says batch size per device to be 1. Right. Now that I see it, I might want to make this like 4, because he sets it as 1 for 2x-T4. I don't know whether I should make it 2, given that I'm running it on a single, whereas he's running it on 2. Anyway, don't want to bog you folks down on just this, but if any of you could also try doing that, obviously you can't do it on Kaggle. Then share with me any progress you make or lack thereof, and we can try and get that experience of fine tuning on a custom data set, fine tuning an LLM, open LLM on a custom data set as part of this competition. So that's what I was trying to accomplish, because that's a good thing to be able to do. And I'll share with you folks, this AI makerspace guys showed how to do it using, again, using 4-bit quantization. So this is something I wanted to try. One of the reasons that Chris was not able to do the training on Kaggle was because I think he said it ran out of memory or was running into problems, but he only used LoRa. So the other thing I wanted to try was using QLoRa, which is quantized LoRa with bits and bytes, and trying that on Kaggle. I haven't gotten around to it, but that's something else. So if that's possible, then you can do QLoRa, which is, you quantize at 4-bit. But again, the problem I'll run into though is I can't hear in this example notebook that I have, which runs successfully, by the way. I'm training it on an alpaca data set and stuff. The data set is different, but the other thing I wanted to point out is that since they do it on an A100, they're using a bfloat16, and they kind of run inference on it too, so they're okay. But I can't do that. I'll have to do a torch.float16 in order to run it so that I can infer on the P100. But that's something else I wanted to try, is to use QLoRa on Kaggle with Mistral and see whether that works, because that would enable it. And if all this fails, then I wanted to try what Mayank had shared and see whether Llama 3, if this data set is possible as well. So anyway, if any of you folks want to give it a shot and share experiences or not, whether it worked for you or not, that'd be great. Because I was kind of ran into problems in both approaches. At least Steve has helped fix one of them, so hopefully I'll make progress on that one. By the way, thanks for joining, Andrea and Terence. Do you folks have any questions, or we kind of jump into, because Mike and Steve and I have been doing this for a while, Andrea, since you've joined newly, any questions, basics on where we're at? Typically, we just decide on a competition and then kind of discuss, as we've been doing, what attempts we make and the problems we run into.
No,
Yeah,
from me.
neither for me. I guess it's hard to jumping in the middle of something, either if you didn't take it from the beginning. But I'm just
by the way,
trying to
there's
catch
still
up.
a lot of time left in the competition, so you can join in, try the Chris Stewart notebook that we are referring to, Steve and I, and so on, is publicly available, so you can just try running that on Kaggle. That works, and get familiarity with what it's doing and so on. And then, so there's still quite some time left in the competition to kind of join in and run some public notebooks, get some understanding.
Mm-hmm.
Yeah, I think there's like just under 2 months left, so there's still quite a while to go. And yeah, I haven't been using these Deberta notebooks at all, really. I've been using like the XG Boost and the Gradient ones, which, yeah, like they just really apply loads and loads of pre-processing to the essays. So that's mostly what I've done. I haven't like really touched the Deberta ones. So I was wondering.
Yeah, but one thing I saw, Steve, my question to you on that one was going to be, I mean, I had several there are some open or openly published notebooks on that front. Did you say any of the top ranking ones that get the 0.82 score and stuff as your base, or?
Yeah, so like all of those top ranking ones, they're all pretty much using exactly the same pre-processing. Like they're using a stack of it. So yeah, like they're just at the minute sort of minor variations on the same pre-processing. And the only thing they do, so they do all the pre-processing and then they apply like the, what is it, LGBM, whatever it's called.
Right.
And then they take all the features that they've made. They take 1,300 features. And the top scoring ones, then they incorporate like a DeBerta notebook as well as features. So
yeah, that's the question I had. So they seem to be using the last or is it the output of the DeBerta model like that they're using as features as well?
That's right, yeah.
So they do pre-train the DeBerta models on the data set and then use that. I mean, there is somebody has provided a data set of that being already done where DeBerta, that's the one that AES something that everybody uses. Is that the one you're using too?
It is, yeah. Unfortunately, they don't provide the training notebook for the DeBerta one, so I haven't. Yeah, like I was going to do my own DeBerta, as I said. Like I took the Chris Diot basic one, so I was going to try like the DeBerta one, but yeah, like maybe use the extra pre-processed features to train Chris Diot's DeBerta one, and like increase the size of the model. I think they use DeBerta large or whatever.
Yeah, that's what I was thinking, which is why I set it up on Colab to begin with. So what you're saying is kind of use Chris Diot's basic notebook, but use a larger model to generate a DeBerta output that would use the large model so you get better embeddings, and then incorporate the output of that DeBerta model into along and combine that along with all the other features that the LGBM guys are using, and then use LGBM on top of their custom features and the DeBerta, a bigger DeBerta model or a more trained DeBerta model to then do LGBM on that, right?
Yeah, I actually saw as well in the discussion that somebody is trying. Do you remember the competition we did before where you had to predict? Again, it was like essay prediction where you had to say there was like 6 categories of the essay. I can't remember what the competition was called.
Yeah. No, I have it bookmarked. Yes, it was more like some argument stuff that we had to say how good the arguments were.
Yeah, you had to say like, was the writing concise and whatever. There was like 6 categories to describe how good the writing was. Yeah, like somebody suggested using sort of the best model from that competition. Like you can go and get like pre-trained versions of the winning models for that competition, and then they were sticking those 6 features into the LGBM model.
I see. So additional, using those as additional features, meaning like if you are able to reason well in the essay, that's a feature that you want to use to give a score to the essay. That makes sense, right? Like if your essay is more cogently put together, then you ought to get a better score.
Yeah, so I was going to give that a try.
Interesting idea.
Yeah, like it was. I haven't seen any notebooks, but it was just in a discussion. So this week I've just been mostly playing about with the pre-processing stuff because they use what do you call it, TF IDF vectorizer and the count vectorizer, and somebody produced a notebook saying that all of the use of those in the sort of top notebooks at the minute, it's actually flawed. Like basically the parameters that they're using to set up the vectorizers, instead of like putting it into like words, it's like meant to go for like n grams or whatever for 2 grams and 3 grams, and like it's actually, because it's using a tokenizer, it's splitting everything into characters rather than words.
Yeah, that's what I saw someone saying. So you are saying that is correct, that their observation is correct, that instead of, I think it was in the comments saying, hey, you're kind of using it wrongly by tokenizing it at the character level rather than the word level.
Yeah, so the person, they produced a whole notebook showing how it's wrong. And so, yeah, like I tried their fix or whatever, which does put it back into words. But like they noted as well, and I've found it myself, that basically the character level one works better, it gives you a better score than the word-based one. So even though the word-based one is probably correct, the character-based one actually gives better results.
So it's kind of that's funny. It's almost like they stumbled on the right answer, the wrong means to get there, because they were thinking they were using words, but they were actually using characters. But the characters thing turned out to be better scoring.
Yeah, it seems to be. Yeah. So
That's
yes.
hilarious.
So
Steve, could you show us some notebooks that you referred to? So
yes, yeah. Let's see. Well, it's just like the top scoring ones.
Yeah, there are 2-3 of them that I was kind of looking into last week. The top scoring public ones, which are at like 0.82, 0.819, 818, all those kinds of stuff.
Yeah, can you see my screen at the minute?
Mm-hmm.
Yeah.
Yeah, so basically, so like just in here, the top scoring ones. So yeah, so this is the one that's top scoring at the minute. But the only thing about, so this notebook here, it's like taken from all these other ones, and all of these other ones, they've got exactly the same pre-processing in them. So yeah, the first bit is, as we said, there's like some DeBerta model that's been trained, and like this is like a public data set that's available with the trained weights of that. But then, like after that, it's all pre-processing. So yeah, so the first thing it does is it takes the text in, like it loads the competition data and it splits it into paragraphs. So you can see here, like it effectively puts it into strings or whatever. And then it's all feature engineering, and they'll do the same. So like here, like this stuff here is just using regular expressions to remove sort of HTML type things. And then they remove all punctuation. Like they just play about. They add like a load of features to say sort of what's the longest sentence and what's the mean length of sentence and stuff. And then they do a similar thing with words, like what's the longest word and the minimum words and stuff. And then these are the vectorizers I was talking about. So here, because of the fact that they use this tokenizer thing, it ends up splitting it into characters and similar on their count vector. So like in the notebook that shows that this is wrong, they take the tokenizers out and then it goes into words, but that doesn't help. And then, so then, like to stick it through.
Oh, this is the DeBerta features, right? If you can go back a minute.
So I'm not.
The thing I was confused about is why do they load the OOF pickle files here? That's something that I was confused by. Meaning, does the pickle file have this model, and they're just kind of extracting the feature names? The features as the columns from the never mind. They are actually taking the 5
I
or
think
6.
I think that's the output of each fold, isn't it?
5 folds, so you would do 0 to 5, but there are 6 then, right? Because that's the other thing I was confused. So they actually have 6 models that they're using in this AES, blah, blah, blah. In fact, it's there as an input. If you can just for a minute go there and check.
No, I think it's like so like when they trained their 5 folds of DeBerta, then they ran each fold to like generate the out of fold predictions. So they're sticking the predictions from the 5-fold models in. So rather than sticking it through the DeBerta, they're sticking in what the result would be in the out of fold predictions. so you don't get like any leakage. So they're
Right,
not
but
actually sticking it back through the diverter, they're sticking what that fooled model predicted. So yeah, so it's not using the 5-fold model. It's not using 5 models here. It's using the prediction from the model itself. So like that's the prediction from the validation fold.
oh, so you're saying it's actually predicting and using the output of the model as a feature.
Yeah. Yeah. So this
But
is
even then, the other question, okay, I got that. But then there seem to be 6 predictions.
that's because of the fact there's 6. Yeah, there's 6 possible outcomes, I think. I'm not sure. Sorry.
Yeah, that is true. But then,
Yeah, I don't
why
know.
would you? Yeah, I mean, that's something I have to figure out as to each prediction. It's almost like you said of each you would predict. Yeah, I mean, I can understand the model's output predictions being used, but I'm then confused by. And I agree that, because there are 6 predictions, but I didn't understand why or how using each of, like 1 to 6 category predictions would be the way to use that.
Yeah, like maybe it's changed it into sort of binary output or whatever, rather than putting in. So say the model predicts it's like number 3, rather than predicting number 3, I think what they've done is, yeah, what do you call it? Yeah, so like the binary output, what's the term for that? Softmax?
Yeah.
Yeah, so I think that's probably
Rather
what they've
than
done.
a sigmoid kind of thing of saying 1 of 6, they've done each one in a binary way and then used the binary. So this model that you were thinking of producing, because that's the reason for my questions there, because then what it would seem to suggest, Steve, is we can't use the Chris-Diot model. It would need to be modified to do a binary prediction on each of the 6 values.
Well, you can use the Chris-Diot model. It produces obviously like an integer output to say what its prediction is, but it's easy enough to convert number 3 into a binary prediction. You just stick a softmax on it. Yeah, so like it's easy enough to, you just like set the binary channel corresponding to whatever the model predicts. So yeah.
Oh, okay. So you would have to stick an head on top of it to say, make it for each of the 6, generate a binary value for each of the 6 based on what. So if, for example, the model predicted a 3, then you would have a output which says a 3 is a 1 and all the others are a 0.
Yeah, so the 3 channel would have a 1 in it and everything else is 0, yeah.
Yeah. So basically, in fact, it's almost like going 1 step below when it produces the 3, right? Because that would be, like you say, softmax a stage before it says the output is 3, because then you would get the actual legits and then do a softmax on the legits.
Yeah.
Okay.
Yeah, so I think that's what they've done, haven't they? But and then the other thing they do is, I'm not sure it's in here. Yeah, they stick it through this. So they just like stick it through the regressor, and like then they take a look to see which of the features are the most important, and then they chop it down to like 1300. So they go from whatever it is, 23,000 down to 1300 using this thing. But again, there's some of the notebooks they save the output of this, so they don't have to do that stage. And then that's pretty much it. And the difference in this notebook is everything else just uses like the LGBM regressor with all of the 1300 features it has, and it fits that. Whereas this one here adds in a second regressor, like an XGB regressor. So it's got like 2 regressors, and then it takes up here they take like a weighted sum of the 2 things. So yeah, I think the LGBM one gives this one, and the XGBoost one gives that one. So, but all of these models are pretty much the same. As I say, the only difference in this one is the fact that it's using the XGB in addition. So like, yeah, it's like effectively got the two regressors on it.
Yeah, in fact, I mean, not that it's complex enough, right, as it is, but another thing then you could do is get the actual output predictions of the Tibeta model and use that as well when you're combining the outputs. You know what I'm saying?
What was that, sorry?
I was thinking another variant of this notebook is, you know, you shared how he combines the two regressor outputs and weights them. But you could potentially, in that weighting formula, add a third, which is the actual output of the Tibeta model, and weigh that. So while you use the softmax of its legits as input to these two models, you can also directly generate output from the Tibeta model, right? And use that as a third component to the weighting.
Yeah.
Can't you do that?
You could do, yeah.
I don't know whether it will help because it's already going into the LGPM, but it gives an independent output as well, right? Because that's at that point, when you share this combination, it's just an ensembling of the two regressors, right?
Yep.
And you could have a third regressor, which is actually the Tibeta regressor itself. Because, here's a thought, right? Because as I understood it, when you showed what is being done with the Tibeta thing, you would probably use the legits of a classifier, whereas you could also run, as Chris Beard's notebook shows, the same thing, the same Tibeta underlying model as a regressor, and then use the output of the regressor as another output to combine with the XGBM and the LGBM regressors.
You could do, yeah.
Okay. Okay.
Yeah, and this is an example of, yeah, like how the TFI vectorizer thing is wrong. So you can see here, like it's like just sticking in these simple sentences. And like when it's got this tokenizer, it splits it into characters. So you end up like with this, as you can see, it's just made like a load of characters out of it. Whereas if you get rid of the tokenizer, then you can see it's doing it on a word level.
It's words, yeah.
But as I say, it didn't give any benefit, so I've taken that out now. Yeah, so that's as far as I've got really, is just playing about with the preprocessor thing. So
interesting. Yeah, I just wanted, I thought it was, besides this, the use of LLMs, at least it gives an opportunity to play around with some LLMs and open source LLMs and training on custom data and stuff. That would be.
Oh yeah, like I think the final solution will be, yeah, like if you can add both in or whatever, then the more the merrier, I would say at the end of it. It's like,
yeah, and then I also like the fact that, at least according to Chris Beard's notebook, it gave a what to me was pretty impressive was the original Tibeta notebook that he shared, where I got, I think, like something in the 0.80 or something, right? Which is pretty good result. And then when I used extra small, he uses small and I used extra small as well, and it gave me 0.794. So that itself is pretty good with the small model. But to train for, I forget, some 5-fold, 3 or 4 epoch each, it took about 6 hours on Kaggle. So you're already coming up on kind of the limit of training time on a 2x T-Force, which is the best you can do on Kaggle. But whereas, the LLM approach that he did, what was impressive to me was he only trained on 3,000 samples of the data and he was able to get a score of 0.77 or 78 or something in about an hour. So I was also impressed with that, because that says if you can train longer and more epochs and that kind of stuff and give the LLM some good workout, which is the reason I wanted to do it on Colab, then with more data than just 3,000, because you have 17,000 and you also have additional data available if you want, then you could get, I thought you could improve and get a very good score. That's the other reason I was motivated, because it's only 1 hour of training and 3,000 examples. He was getting the LLM to do really well. I mean, 0.77 and 78 or something is pretty good with just an hour. Now, of course, the question is, does it get any better when you throw more data or more training time at it? That's an open question.
Sorry, I need to drop off here. The sun's come out in Manchester, so I'm off to a barbecue tonight, so I'll have to head off.
Cool.
Oh, awesome.
So,
It
hey,
doesn't happen
one
very
other
often.
comment just before you folks, before you leave, Steve, is I may be traveling next week, so I'll request mine to host it, and if you can also post a recording, I at least will definitely look at it. I haven't been posting recording because most people who are interested join anyway. So just a heads up, I may be on the road next week. I'll confirm the next day or two. So.
Okay.
Cool.
All right. Well,
So
I'll speak to you next week, guys.
take care.
See you.
Okay. See
So
you later.
the competition is the Learning Agency Lab automated essay scoring, right?
Yes.
Is that the one? Okay. Yeah, definitely. I've missed the last few sessions, so if you could post the recordings, that would be awesome.
Yeah, I'll post the recordings. So, Mayank, you may need to run it. I'll confirm and send you a DM later this week.
Mm-hmm.
I might be
Okay.
on the road. Any other thoughts or questions? Mike, let me know if you try in your setup the Chris Stewart thing with LLM, because I know you've had some experience with it, and I'd like to hear whether you run into similar problems or you're okay in your setup to be able to make it work. So I'm curious.
So, but as you said, it won't lead to anywhere, since the the end-to-end workflow part is still not, I think so, integrated to the CUDA notebook that you the notebook that you alluded to earlier. So I am thinking it may be a fool's errand to do that.
So I mean, he has successfully done it. It's just that he has unfortunately not posted the V100 training thing. And I'll post a note saying, hey, when I run it in Colab with he's usually responsive. So I'll ask him if I were to try it. And he also says that, hey, I haven't used the SFTT trainer, but I was just curious if you were to play with it, what you see. I mean, it isn't that it completely fails. It's just that there are some niggling issues that you'll have to work around. So, which is what I'm curious about, of how many problems you run into when you try to do that.
And since I will have memory issues first and foremost, since I have only 8 gigs of VRAM. So I'm thinking if I run that, the Mistral one.
Oh yeah. 8 gig will not fly. Yeah, you need at
Yeah.
least 16 to 24. Yeah, the 8 gig won't work. Yep. Okay.
So I was thinking about that too. Maybe Llama 4-bit quantized, but I don't know if
No, even that, because you're at 8 gig, I mean, it's like 8 billion. So even if you do 4 billion and shrink it on LoRa, you're not going to, I don't think, get within, because 8 itself is, if you think 4 bytes per, that puts you at 32 gig. And then I don't know that you can get it from 32 gig down, even with quantized LoRa, to below 8 gig.
Yeah. If I have a preloaded model, then I can. But I tried on my machine to quantize it, to quantize a FP16, the B float 16 one, sorry, the Llama 3 into 4 bed, but I wasn't able to do that due to my memory limits. So
Yeah. The only thing I was thinking of, and in which case you don't have to even do all this PEF things and all that. You can just directly fine tune. Is I might try that, but I do know that wouldn't be that great, I would imagine. But another thing I had on my list to try along the LLM route was just using a 5.3, which is I think 3 or 4 gig, right?
yeah, the 5.3, the 1.5 billion one.
Yeah.
It's small, but yeah. Okay, so
Because that you should be able to fit in, right?
yes, the FP16 5.3, that might fit in. The 2 billion one or the 1.5 billion one, the Gemma 2 billion or the 1.5 billion one, I
Yeah,
might able to.
yeah, those were the other two I was thinking of trying as well. Because then you don't even have to do any
Quantize
LoRa
it,
stuff.
yeah,
You
yeah.
can just directly go to fine tuning using the entire model.
But I don't know what the fine-tuned model will respond to. I mean, yeah, the dataset is custom, but that custom dataset will output that particular uh, the score will be good or not. I'm skeptical about that.
Yeah, but at least this is the whole point, right? Like, how good are these models on, everybody kind of has their notebooks showing some fine tuning, but here is a practical fine tuning example. If we are going to use any of these models on actual our quote unquote our proprietary data and see, I mean, yes, Llama 3 and those things are much bigger, better, but 5.3 also, from what I saw, is not anything to sneeze at. And so I'm just really curious of when you have this much data, and it's not like 1,000 data points, you have 17,000 data points to fine tune it on. So I'm really curious how poorly or how well does it does? I mean, does it do a 0.7, 0.8 kind of thing, or is it like at a 0.5 point? It's kind of really, because right there is then a significant gap between the models. I'd like to really understand and know that, right? Because right now, if you ask me, I can't tell you how good is a 5.3 or I mean, generically people say, yeah, of course it's a much smaller model, so it will do poorer. How poor is it on, and how bad is it if you can fine tune it on some things?
I think so. It will be bad as compared to the Mixel 7X model that you used. So
yeah, but even on Mistral, I mean, of course, he's the guy who has produced some results, but even that, I mean, is pretty impressive given he has only trained it on 3,000 examples, right? That's where I'm more optimistic that if you use a 5.3 model, even though its parameters are relatively small, you can fine tune it on 17,000 examples. And does that fine tuning really help? So anyway, I'm curious. I'm still going to push through to see whether it gives me any, and what kind of results it gives me, even if it gives me poor results. Where in the range does it land?
Since the model size is small, I think so the 1.5 billion or 2 billion. So I don't think so the scores will be much uh, uh, much much poorer. I think so. It
Yeah,
will be
but I'm
poorer
not
than this.
convinced totally of that. That's my point. Because the other thing that I've seen in the little bit of reading I did around 5.3 especially is, one of the advantages 5.3 has, and the reason it performs so well on some of the benchmarks, of course, poorer than GPT-4 or whatever, but still remarkably well for its size, is because the data they use for it is much cleaner than, just the torrent of just internet corpora that is thrown at models like GPT and Claude
Yeah.
and all that. I mean, the Py3 models are trained on a much cleaner data set. So that's the other thing, right? Like just knowing, my goal is not to win the competition using this, but my goal is to figure out use the competition as an excuse to learn fine tuning of these long-range models and then figure out where they end up. A Llama 3, a Mistral 7B, and quantized and stuff, and then compare that to a 5.3 where you don't have to do any of that, and at least gain an understanding of where they end up, comparatively speaking. So anyway, that's at least my quest to get out of the competition besides just the routine stuff.
Yeah, I think so. The Llama 3 8 billion one might have a high score as compared to the Mixel one that you trained on. So that quantized model, I will try to take a look at that if I can use that in my training process. Other than that, yeah, I will try that in steps and see if I can include them in my training workflow, and does that give a positive result or not?
Sounds good.
Yep.
Okay, I'll let you know later this week whether I'm able to host or I'll need you to help out. And I'll post the last couple of, I think, was it only last week that was our discussion, Mike? I think only last week, right? The week before is when we decided to do the competition. So I don't think parents that there are multiple weeks. It's just last week.
Just last
and
week.
possibly
Okay.
this week.
That's awesome. Okay. Cool.
Okie dokie. Thanks for joining, folks. And
thanks, everyone.
Join again next week and have a good discussion so at least I can follow along.
Awesome. Okay. Take care, everyone.
Goodbye. Take care.
Bye.
Thanks.